This video introduces research on remote operation of USVs conducted by the Shimizu Laboratory at Tokyo University of Marine Science and Technology. We implemented a remote control system on a battery-powered boat managed by our laboratory and conducted many experiments. However, the following issues were identified. We needed a lot of people with small boat licenses. The experimental area was limited and required many procedures. Difficulty in transferring research between generations, including program modifications. Furthermore, teachers are no longer able to dedicate enough time to experiments. Based on these experiences, we became involved in rule-making activities. While the IMO is working on developing international rules regarding autonomous navigation, some countries have established various exemptions from existing rules depending on the size of the vessel in waters where domestic law applies. Our laboratory is also involved in these rule-making activities. Next, we will outline the exceptions concerning small unmanned surface vessels. The Ministry of Land, Infrastructure, Transport, and Tourism has published safety guidelines for remotely operated small vessels. The navigation area of a USVs is, in principle, limited to within 3 nautical miles from the remote control position, corresponds to visual line of sight. Operating USVs from beyond the visual line of sight distance requires a case-by-case exceptions. The following describes laboratory experiments related to additional functional requirements. We experimented with several communication methods. We also measured the characteristics of data transmission and studied the competence of the operators. A fail-safe function was also developed that monitors the communication status and maintains a fixed point in the event of a communication interruption. The system configuration will vary depending on the operational requirements and available platform, so appropriate system design is crucial. Experiments related to case-by-case exceptions have also been conducted. Situational awareness typically involves the use of cameras and image recognition technology. In vessel navigation, it is also necessary to recognize objects at a distance, so we are also working on optical challenges in long-range situations. We also verified the communication characteristics when using low Earth orbit satellites, which are said to enable high-capacity communication, as well as Wi-Fi. When using land-based systems at sea, it is necessary to design the system with an understanding of the various limitations that exist. The information that should be transmitted to the remote operators via radio communication includes their own position. GNSS is widely used for positioning, but in recent global events, GNSS jamming has also been frequently observed. Furthermore, in urban areas, there are many environments where there is no clear line of sight to the sky, such as under bridges and elevated structures. Understanding these environmental characteristics is also important. We still need to work on performance evaluation methods for USVs. On the other hand, since they are becoming somewhat usable, we must also create a market for utilizing USVs. One such application is MDA. When considering MDA, we realize that we need not only USVs, but also equipment tailored to the application, such as satellites, aircraft, and underwater systems. Therefore, we have also started research on HAPS, a type of aircraft, in which research and development has been relatively slow. The importance of MDA is increasing, and we are considering actions to enable USV operation in areas beyond visual line of sight. We also plan to conduct research on other requirements outlined in the guidelines. Thank you for watching.